Okay. So, small review just in case. Equilateral triangle, isosceles triangle, acute, obtuse, right, and scalene. You know what all of those are.
Sausage is when it's two the same one.
Two are the same. And the key with isosceles is these base angles are the same. This is a terrible equilateral where
Really
all
bad.
the angles are the same. Yeah, really bad equilateral.
Maybe they have a computer. They could have made this.
This really wasn't that hard. Yeah. So triangles are very strong because they apply pressure in all directions. Sure, your dad can give you a better explanation of that. He took more of that physics. Um, Theory of knowledge, you discuss various theories. One such theory is the correspondence of theory of truth. In short, the theory states that which is true corresponds to the fact in reality that truth is a relational property. This theory relates mathematics insofar as mathematics corresponds to reality. In the examples provided in this section, mathematics is used to build bridges. Correspondence theory of truth would hold that if buildings don't fall down, the mathematics used to create them is true, for the most part. In social sciences, this is referred to as having predictive validity. Consider that knowledge question, does math necessitate real-world consequence in order to be valid? I would argue no, it doesn't have to have real-world consequence to be valid math. Potentially to be currently useful math, yes. So right triangles, hypotenuse. Adjacent side to beta, opposite of beta. This would be opposite of alpha and adjacent to alpha. A right-angled triangle will be identified as right-angled when written in the question. Even if the triangle appears to be right, should only treat it as right if it has a marking or it is said to be right. Or you put in a right triangle. Yeah, don't assume because it looks. Ever in any math class, if you draw in the triangle, you can say it's right. If you're making a right triangle to be in there, and we'll do that a lot. Um, Hopefully you remember SOHCAHTOA. Sine of an angle equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So in this one, ABC. In the cosine of A being the capital here, is 3 over 4. Find sine A and tangent A. So in order to find this, I need to find the third side. I don't know what x is.
4 squared plus x squared. The square root. Wait, no, x squared plus 3 squared.
So x is square root of 7. 16 minus 9. Even though it does not look like that, square root of 7 is less than 3. Sine of A is opposite over hypotenuse. Tangent of A is opposite over adjacent. Here we are told that the sine of A is 3/5. Find the length of the other sides. We don't know the angle. We know this is 22. This is a little different twist, actually. So sine of A, we're gonna have that's x, right? The sine of A is 3/5. It's also x over 22. So we're gonna set up the proportion. That is not something I think I've ever done anywhere else. Although it is a pretty simple problem. Solve the proportion. I'll just multiply by 22 instead of totally cross multiplying. 66 fifths, which is like 13.2 or something. But I like the fraction. Okay, finding the missing side using trig. Find the length of it once AB. So that's a sine again, because that's opposite of my angle equals sine opposite over hypotenuse is 11. And multiply both sides by 11, 11 sine 51. 8.55. And because it has a label, make sure to use it. Um, you can watch this proof of the Pythagorean theorem. There's several proofs. Pretty sure I did one in integrated two. Different one that I like better because I think it's a little easier. Um, in this drawing, a right-angled triangle D equals 44 degree, angle E equals 90, and DE equals 6. Find the side length of DE or DF. This one I've got adjacent. I'm looking for hypotenuse. So I want a cosine. To solve this, I multiply both sides by x and then divide both sides by cosine 44. Always make sure your calculator is in the correct mode. 8.34. Okay, what are they asking me for on this one? JM is 10. KJM is 63. They want the sides KM. Let's call that X.
Not.
JK, we will call Y. ML, we will call it Z.
The length of basically all of the unknowns.
JL, yeah. We're going to call Q. So I'm going to find X first because I feel like it. I know that's 90. I know this is also 90. I know that this is 27 because the big triangle's a right triangle. So, and I know that bottom is 10. So let's find X first. Sine of 63 equals X over 10. 'X is 8.91. I think I'll use Pythagorean theorem to get Y. Um,
There's like so many ways to solve this.
there's a million of them.
Information. Okay.
4.54.
We're gonna go by the bird. By word.
So that makes sense so far. I think I'll use tangent of 63 to get. No, I'm going to use tangent of 27 so I can have the 10 on the bottom. Felt easier. Nope, I want tangent. I did that wrong. Opposite is of 20. I want opposite of. I want adjacent on bottom. That's got to be 63. So sometimes I screw up, but if you recognize your answer, 5.09 is ridiculous for that side length, right? So
Yes.
19.62. That makes more sense. And then I want to use Pythagorean theorem for Q. And there we have our right triangle. Yes, there are a million ways to solve these sides. Finding the angle, you use an inverse. So to get this angle, I would use, this looks like a sine relationship, opposite over hypotenuse.
Then if you're upright,
17.5 degrees. Area of a triangle. There are 3 area of a triangle formulas. There's this one. There's this one, which, if you do B sine C, is equal to H. If you literally just set up a trig ratio on, it's probably easier to see on this one, but it works on that. As well. There's also this one, which isn't really an IB, but it's probably good to know. It is on the square root. Where S is called the semi-perimeter, half the perimeter. We will be using this one a bunch, though, in this class. They like that in cognitive. I don't know on the exams.
The one with the square root and everything, that one's also area.
That's also area if you know the 3 sides. It's called Heron's formula. We did it a little bit in pre-calc.
Yeah, I just don't remember. I'm sure we like proved it or something. I believe it.
Yes.
No. But
It's that one's sometimes useful. We did I'm pretty sure I could figure out the proof, but I don't know it offhand. Um, find the area of this triangle. Yeah, look at how easy it is with this new formula. The key is that these sides are around the angle.
not saying that myself. It's too little.
It's nice dress though. Devin's best counts though, right?
Wait, so.
His hair counts.
Wait, so.
And Elise has on red under her white shirt.
Wait, I saw that. Which sports workout? Yeah,
Yeah.
close.
So
Okay,
then how
three,
many-
10? 9 plus 1 bonus.
One bonus. Okay. The bonus could be important.
Teachers a bonus, and I thought that was discussed yesterday. Apparently, it wasn't. The people didn't. Last teacher, like I was.
Hmm.
No. Wait, so the bonus I counted. What?
Like we're a student, so I feel like it definitely counts.
Well, they have to follow the rules. Let them follow the rules that are defined. We want to win as a high school fair and square.
If they said the hair counts, they said the hair.
It's up to them.
The first time I asked them, they said yes, so.
Okay, here's where it gets a little interesting. The area of both triangles are 98 centimeters squared. Find the angle at A for both triangles.
Oh, so cute. The other one's on James.
Mhm. Yeah, so if we find one, we can just do 180 minus for the other.
Two of their sides are the same length.
Yes,
So they
So-
both have a 13 and they both have a 17.
yes.
This is helpful.
Uh-huh. Fine.
That's the opposite. See if you can do it.
A. Darn it! A is used twice in this problem. Area.
That's okay, that's good.
Area. There we go. 1/2. 110.5. So this isn't so bad. We do the inverse sine.
Oh,
62.5 degrees. So that's this one. The other one is just 180 minus. And if they hadn't given you the same lengths, you still could have done it. Correct? You just would have to do it again and then do 180 minus. So, a land surveyor is asking about the area of a piece of land they walked around. Find. So, if you want to do the area of this, I would just split it and do the area of this triangle plus that triangle.
There. Well, I didn't eat one. Oh, okay. No.
and we just type them in. Oh, it's important to use the right angle, the correct one. 2,400 and no 2,400. Written it properly to three sig figs of that. We'll see how they reported it. They just they just called it 2,400. They didn't properly report it as sig figs, but that's fine. Make sense? That's it for today. We'll do law of sines and cosines tomorrow.
Scott doesn't really accept
The scientific notation. Okay.
like if they say three sig figs, they'd take
Big.
2,400 instead of 2.
2.4 times 10 to the third. Okay.
Because I think it's just because there's like less error for people to like.
I think
Notate.
they're really just open to,
Versus decimal, for example.
they're not,
They have to enter in more answers to the program.
yeah,
So it's like
they're not super fussy on sig figs as long as you show them and don't round until your final answer.